Hello and welcome. E-learning platform provided by XII classes. Myself, Mr. Kishore Kanse. Today we are going to discuss the topic ionic equilibrium from the 12th science class. The syllabus framed as per the Maharashtra State Board syllabus. Content of this topic is there are 10 points. First is introduction, second types of electrolytes, third acids and bases, fourth ionization of acids and bases, fifth ionization of water, sixth pH scale, seventh hydrolysis of salt, eighth buffer solution, ninth solubility product, and 10 is the common ion effect. We are going to discuss one by one. First we will start with the introduction. The topic name is ionic equilibrium. Before we start, we have to know what do you mean by equilibrium. Equilibrium means the state at which concentration of reactant and product do not change with time. Means in any reaction there are two parts. First is reactant, second is the product. At the starting of reaction, the concentration of reactant is 100%, while the concentration of product is 0. With the time being, the reactant is converted into product, concentration of reactant reduces and concentration of product increases. At one stage, the concentration of reactant and concentration of product becomes equal and they do not change with the time. Such state is called as a equilibrium. Same way, it is the state where the state of process in which properties like temperature, color, pressure, concentration is unchanged with respect to the time is called as a equilibrium. There are two types of equilibrium. First is the physical equilibrium, second one is the chemical equilibrium. Physical equilibrium involves the physical changes while the chemical equilibrium involves the chemical changes. Example of physical equilibrium is melting of ice into water, and chemical equilibrium involves reaction between hydrogen and iodine. Now what do you mean by ionic equilibrium? Means whenever any compound dissolved in a specific beaker, it mainly if it is not fully soluble or it is not the strong electrolyte, then some amount is converted into ions and some amount is as such in unionized molecules. The equilibrium between ions and unionized molecules in the solution is called as a ionic equilibrium. Like in chemical reaction, there are two parts. One is reactant, second one is the product. In ionic equilibrium, there are two parts. The first part is unionized molecules and second part is the ions. The equilibrium between these two in the solution, it is said to be ionic equilibrium. The examples of ionic equilibrium are equilibrium between ions of water like H plus and OH minus ions and unionized water is the one of the example of ionic equilibrium. Ionization of weak acid and weak bases. Reaction between ions of salt and ions of water. Solid salt and its ions in the water. One thing, why ionization of weak acid and weak bases, not the strong acid and strong bases? Because strong acids and strong bases are the strong electrolytes which are completely converted into its ions. So unionized molecules near about zero. So in this topic we mainly consider the weak electrolytes, either weak acids or either weak bases. Now the electrolytes. There are mainly two types of electrolytes. First is the strong electrolytes and second one is the weak electrolytes. Before that, we have to know what do you mean by electrolytes, what do you mean by non-electrolytes. When any substance is dissolved in water, if it is ionized, then it is said to be electrolytes. When a substance dissolved in water, it does not ionize and it remains or exists as a molecules. Such substances is known as non-electrolytes. There are mainly two types of electrolytes. First is strong electrolytes, second is the weak electrolytes. The classification of these two is on the basis of extent of dissociation or ionization. Strong electrolytes are the electrolytes which are ionized almost completely, while weak electrolytes are the electrolytes which dissociate or ionize in a little extent. Examples of strong electrolytes are strong acid, strong bases, and salts, while the examples of weak electrolytes, weak acids and weak bases. Strong acids, strong bases, weak acids, weak bases. Along with that, salts are the converted into its ions when dissolved in aqueous solution in a higher extent. Example is sodium chloride, that is common salt. Which common salt we dissolved in water, it is converted into sodium plus and Cl minus ion in a higher extent, near about completely or in a higher extent. So it is considered in a strong electrolytes. So there are two types of electrolytes, strong electrolytes and the weak electrolytes. Now what do you mean by degree of dissociation? If we have the 100 moles which are dissolved in water, from that 20 are ionized or dissociated. The degree of dissociation alpha is the ratio of number of moles dissociated to the total number of moles present. Suppose 20 moles dissociated divided by 100 is the degree of dissociation. Percentage dissociation, it is degree of dissociation multiplied by 100. So if C is the molar concentration of an electrolyte, equilibrium concentration of cation or anion is C multiplied by alpha, mole per dm cube. Dm cube means mole per liter. The third point is concept of acids and the bases. The acids and bases are explained by using three theories, mainly by using three different scientists. The first theory is Arrhenius concept or Arrhenius theory. Second is Bronsted-Lowry concept, and third one is the Lewis concept. We are going to discuss how they explain acids and bases. The first theory is the Arrhenius concept. As per the Arrhenius concept, acid is the substance which mainly consists of hydrogen, and whenever they are dissolved in water, they dissociate into hydronium ion, as we also consider as a H plus ion. And base is the substance which mainly consists of hydroxyl group. Hydroxyl group means OH group, and dissociate in water to yield OH minus ion. So acid which contain H and dissociate as H3O plus, and base is the substance which contain OH and dissociate as a OH minus ion. The reaction between hydronium ion and hydroxyl ion, as we all know, the reaction between acid and base is called as a neutralization reaction. So ion of acid react with ion of base, it gives the water which is a neutral. Example of Arrhenius acids and bases. Here HCl, H2SO4, MgOH, twice KOH. In HCl we have H, so it is acid. In H2SO4 we have H, so it is base. In MgOH twice we have hydroxyl group, that is OH, so it is base. In KOH we have OH, so it is base. So, but although very simply or easily we can identify whether it is acid or basis, still the Arrhenius theory have the few limitations. It is dissociates in water. It means it only gives information regarding acids or bases only in aqueous solution. So it is applicable only to the aqueous solution. And few substances like ammonia, Na2CO3. In ammonia we have H, we don't have the OH, still ammonia is the base. Na2CO3, we don't have H as well as OH, still it is the base. So Arrhenius theory have few drawbacks, that is theory is applicable only to the aqueous solutions. It does not account for the basicity of NH3 and Na2CO3 which do not have OH group. The second theory is Bronsted-Lowry theory. As per Bronsted-Lowry theory, acid is the substance which donates proton to the another substance, and base is the substance which accept proton from the another substance. Proton is the H plus ion. The example is when ammonia react with water, it gives NH4 plus ion and OH minus ion. Here NH3 is converted into NH4. Number of H is 3, number of H is 4, means it takes one H plus from whom? From H2. So it accept proton, and H2O donate proton and converted into OH minus ion. So H2O is the acid, NH3 is the base. While if we consider the reversible reaction, NH4 donates proton to OH, so it is acid, and OH accept proton from the NH4, so it is base. And the one base and one acid, it forms conjugate acid base pair, while one acid and another base, it form the another conjugate acid base pair. If generally if the stronger is the acid, weaker is the its conjugate base, and stronger is the base, weaker is its conjugate acid, and vice versa. Here is the diagrammatic representation. Water react with water. One water molecule which donates proton acts as an acid. One water molecule accepts proton and acts as a base. Acid, here it donates proton, hence it is acid, and base which have two proton or H which accept one from the acid, so it is the base. Another representation, HCl who donate proton acts as acid, who accept proton, water acts as a base. NH3 who accept proton, hence it is base, water donates proton, acts as a acid. Here are few reactions. The pattern is when acid is react with base, it is converted into base and acid. Acid from the reactant and the base from the product acts as its conjugate pair. Base from the reactant and acid from the product also another conjugate acid base pair. We will discuss one reaction. Suppose here NH4 plus react with CO3 2 minus, it produces NH3 ammonia and HCO3. Here NH4 is converted into NH3, means it donates proton, so it is acid, while CO3 is converted into HCO3, means it accepts H proton from the NH4 plus, so it acts as a base. NH3 is converted into, if we consider the reversible reaction, NH3 is converted into NH4 by accepting proton from HCO3, so it is a base, and HCO3 by donating proton to NH3, it is converted into CO3 2 minus, hence it is the acid, and same for the all reactions. And the last theory is Lewis acid base theory. Lewis acid base theory is based on shear in an electron pair or lone pair of electron. The one who donates lone pair of electron is the base, opposite to the Bronsted-Lowry concept. In Bronsted-Lowry concept, one who donates proton is acid, but in Lewis concept, one who donates lone pair of electron is the base, and one who accepts lone pair of electron is the acid. Here example of NH3 plus BF3 gives NH3BF3. Here NH3 have a lone pair. NH3 donates lone pair to the BF3. It donates, hence it is base. It accepts, and hence it is acid. So NH3 is the Lewis base, BF3 is the Lewis acid. As shown in figure, NH3 donates lone pair to the H, so it is base. H accepts lone pair, hence it is acid, and it forms the NH4 plus. Same way BF3 accepts lone pair and it acts as an acid. NH3 donates lone pair, hence it acts as a base. By combining these two, it forms a new structure. While what about the water? whether it is acts as acid or whether it is acts as a base. We will discuss. When water react with the ammonia in one reaction and water react with HCl in another reaction. In first reaction, NH3 acts as a base while HCl acts as a acid. The reaction between H2O and NH3 by donating proton to the NH3, it acts as a acid. By donating proton H plus, it is converted into OH, to whom it donates proton to NH3. While NH3 by accepting proton, it acts as a base. So whenever we react water with the base, it acts as a acid. In another reaction, whenever we react water with HCl, that is acid, it acts as a base. Here there are 2H, here there is a 3H. So to convert H2O into H3O plus, it have to take one proton. So it is accept proton from whom? From HCl. So water acts as an acid when reacted with the base, and water acts as a base while reacting with the acid. So water acts as a amphoteric nature. It acts as acid as well as it acts as a base. By comparing all three theories, as per Arrhenius theory, the substance which have hydrogen and produces H plus on dissociation called as acid, substance which have hydroxyl and on dissociation gives OH minus ion acts as a base. While as per Bronsted-Lowry, substance which donates proton acts as acid, substance which accepts proton acts as a base. As per the Lewis theory, substance which donate lone pair of electron acts as a base, and substance which accept lone pair of electron acts as a acid. So in this video we discussed about introduction, types of electrolytes, acids and bases. In further video we will discuss the further points. Thanks for listening or viewing the video. If you are new on channel, please subscribe our channel. Shivanya Classes YouTube channel provides educational videos related to the mainly related to the 12th science. Thank you for listening. Thank you one and all.